distance from the center point, a distance from this one we say R, and this point we can say as P. So now we are going to find the potential, and we define by pi, and as well as that electric field. So as we yesterday described, we just draw this diagram like a trigonal like this, and we define this as a theta. And also we just name this displacement R plus and this one R minus. Okay, so the basic theory of this electromagnetism, we know that how to find the magnetic here. Okay, so how to find the potential. So we know that the potential pi is equal to the potential due to the plus charge plus q, and also the due to the minus q. So we know that the potential is equal k we know that it's equal to 4 pi epsilon naught r plus minus the charge minus charge q, and also 4 pi epsilon naught r minus. Okay, so I'm just going to have the common terms here, that is q over 4 pi epsilon naught, and inside the bracket we can have that this is the r plus value and minus 1 over r minus value. So now can you just write down that how using the cost rule, how can we find the r plus and also r minus? Can you please do it yourself? So when I ask you in the registration number, please respond for me. So how can you write this? R squared, if we consider this trigonal here, then R plus squared will be equal to this displacement we already defined as d by 2. Here also d by 2. So A squared, that is d by 2 squared, plus that this displacement, we know that that is R. So that is equal to R squared minus 2 times R times d by 2 times cos theta. So this is the cos rule. Okay. So here, what we are going to do, I'm going to just have that R squared outside. Okay, so I'm going to have the R squared outside. So if I have the R squared outside, then what I can have here as it is 1 plus, we already have d by 2 all things squared. So if I take R squared outside, then it should be divided by R squared. So how can I write this? D over R all things squared minus time these 2 and these 2 will be cancelled, and also I'm having R squared outside, so definitely we need to divide by R squared here. So R and the power 2 will be cancelled. So what we can have here, d over R cos theta. Okay, is it clear? So if you have any doubt with this mathematics, just ask me. So similarly, can you please write down the answer for the R minus? Please try it yourself. Okay, so as we use the same cost rule here, how can we write this R minus, this page or this side R minus? We know that by just considering that the downside one. So R minus squared will be equal to this page one side R d by 2. So d by 2 all things squared plus, and the other face we can say this R. So r squared minus 2r d by 2. And here we need to define the cos theta. That angle theta should be the opposite to this, the phase where we consider. So that should be here. So what the theta we are defining here, that should be given this angle. So we know that this line, that a straight line having the theta and this angle. So this angle will be equal to pi minus theta. Am I correct? So now if you have this idea, then what we can write, this is equal d by 2 all things squared plus r squared minus these 2 will be cancelled, and what we can have r d cos pi minus theta. So what is the value of this cos pi minus theta? Anyone? PS 97? Physical science 97?
Yes, ma'am. Minus theta.
Okay. So I hope you others also know the same answer, because we know this is the trigonometry. We know that if we have cos pi minus theta, then we can write on as a minus cos theta. So what we can have here finally, if we take as we did for the r plus, if we take out this r squared outside, then r squared, and here we can write 1 plus d over 2r all things squared minus d over r, same cos theta here. So we can write this cos theta. But here also we are having minus value, therefore it will be as a plus. Okay, so if we use the cost rule, you can find easily the r plus displacement and also r minus displacement. But you should keep remember here, when we have the r plus, we are having minus value here. And when we have the r minus value, then we are having the plus value here. Okay, so when you use the cost rule, automatically you will get this answer. Okay, so now we know that the potential, we already written here, potential is equal Q over 4 pi epsilon naught, and inside the bracket 1 over R plus minus 1 over R minus. So if we know the value of R squared, then if we get the square root of these values, then we can have the R plus and also R minus. So can you please substitute that value here for to find the potential? So potential is equal Q over 4 pi epsilon naught time 1 over the root of, so if we take root of for this r square, then I can have r outside. R 1 plus d by 2 r all things squared minus d by r time cos theta. So this will be the value for r plus. Okay. So I'm just deleting this the process how we got that r plus and r minus. Okay, I'll just delete this one. Okay, so just to continue this. This is actually what we wrote for the 1 over r plus. Now the remaining values, this minus and also 1 over, as we get this r minus here, also we can have the r. So r time root of 1 plus d over 2r all things squared plus d over r cos theta. Okay, now as we already written this, so I'm just erase that r value here. Okay. Okay, so now we know that this is the potential, but it's a very complicated formula here. We have the lot of notations R, D, and also we don't know the value and the exact the parameter of this one. So what we are going to use some of the mathematical formula to just make them simply. Straight here. Okay. Okay. So I'm going to write here 1 over this one. So here you can see here also we have r and here also we have small r. So what I'm going to do in next step, I'm going to take out all the r. So that will be equal to q over 4 pi epsilon naught r. So what we have inside the bracket, the remaining one will be without this r. Okay, I hope that you can write down here. So 1 over root of 1 plus d over 2r all things square minus d over r cos theta. And also minus 1 over root of 1 plus d over 2r all things squared plus d over r cos theta. Okay. And we already know that yesterday also I just wrote that the displacement or the separation between these two charges are very small. So I already told you it likes a very closed one. So this D is much smaller compared to the displacement where we consider the potential from this dipole. Dipole. So if the D is much less, what we can say d over 2r or d over r, all this squared will be much less. Am I correct? So if the d is much small, then d over r, all things squared, or d over r squared, then will be close to 0. It close to 0. So we can just neglect the term, this one, and also this one in this step. So how can you write the remaining one? The potential is equal q over 4 pi epsilon naught r time inside the bracket 1 over root of 1 minus d over r cos theta minus 1 over 1 plus d over r cos theta. Okay. So now we need to find the value of the root of 1 minus something. And there's some mathematical relationship to find that the value for a plus b or in the format of root of 1 or 1 plus x. For example, so after just write this line, you can write down that if 1 over any function, but we have 1 over 1 plus x, then this can be written as a 1 minus half time x plus 1 over 2 factorial time minus half time minus 3 by 2 x squared plus something like this. This series will be continued. Okay, so if it is 1 plus x, then we can have the first value as 1. Then if we have plus value here, the second term will carry the minus. And other one plus, other one minus, something like that, it will be continued. So likewise, if you write it for the 1 over root of 1 minus x, can you just write down the answer? If the series having these relations, can you just write the answer for 1 over root of 1 minus x? Can you tell me the answer, anyone? PS101? PS101? Are you there? PS140?
Yes, ma'am.
140?
Yes, ma'am.
Can you tell me your answer?
1
And
plus
also
1
just
over
properly mute your mic.
2x.
I couldn't hear your voice properly.
1 plus 1 over 2x
Mm-hmm.
minus 1 over 2 factorial.
Can you also tell me the answer for 2 factorial? What is the value of 2 factorial?
2
Okay, thank you. So, yeah, okay, continue that.
minus half minus 3 over 2x squared minus
Okay, it will be continue like in that series. Okay, thank you. So, as she told that, how can you write this as 1 plus half x? And here we have that, as he already told that 2 factorial is equal to 2. That means 2 factorial means we need to write down until what we have this value 1 into 2 that is equal to 2. So half x, and here we are having minus value, and okay, as she told that the series will vary the minus here, and here also we have minus, here another minus, so again the minus value will be here. Minus time, here 2 and 2, here also 2, so what we can write 3 over 8 x squared plus something like this, it will continue. Okay, now we will use these mathematical relations to find the value for the potential. So I'm just writing here. Is this letter clear? This color is clear for you? Can I continue with this color? If you don't respond, so I can't just mean that. Okay, thank you. Okay, so the pi is equal q over 4 pi epsilon naught r, and now I'm going to apply here inside this bracket. So what we have 1 over root of 1 minus something d over r cos theta. What I can do, I can make this one as it is 1 minus this is, I can consider this one as a x. So what is the series we can have if we have root value here? 1 over, okay, we can directly apply here. So I just delete these. Give me some time. Okay. Okay, so here, can you tell me the answer? What we can write here for the value for 1 over root of 1 minus d over r cos theta. Can anyone write down this answer? Can you continue with me? Anyone? At least any physical science students? No one is ready. PS 150. Sorry, 157. PS 157.
Yes, ma'am.
Okay, can you just tell me the answer? What should be here?
1 plus
Okay.
d by 2r,
Sorry?
d by 2r
Okay. D over 2r
cos theta
cos theta.
minus
Okay, minus 3 over
1
8. Yeah, tell me.
1 over 2 factorial.
Okay, so we can have the multiplication of this one that will be equal to 3 by 8. Am I correct?
Okay, okay.
Okay. And also, okay, thank you for your answer. And also you can consider here, we are having the x squared value here. And we know that if we consider this one d over r cos theta as a x, then we can have the x squared d squared over r squared. But we already have now this condition, this value d is much greater than r. So if we have the term d over r squared again, that will be close to 0. Okay, therefore, what I'm going to do, I just neglect this term here. So only 2 terms will be there. Okay, so this term will be equal to this one. That means 1 over root of 1 minus d over r cos theta will be equal to 1 plus d over 2r cos theta. And now we are going to do for this term. Okay. So minus time. Okay, I'm just make this one bracket minus time. Here what we have 1 over root of 1 plus x. Something like 1 plus x. So can anyone continue the series of the answer of 1 over root of 1 plus x? Can you just continue here? Anyone? Okay, if you're not ready to do that, I can call you. BS 66, Bioscience 66. BS 66, are you there? BS 95. BS 95. If you're not available, then I will remove your name, okay? I will remove you from this meeting. Biological science 119. Are you there? PS 56. PS 56. PS 81. PS 81.
Yes, madam.
Okay. So can you just tell me the answer for this? Can you hear me? Okay, just you can think about this minus time. But we can write here, we can just follow the same method here. So we can write it as 1 minus half of x. X we have here d over r cos theta. So that will be d over 2r cos theta. And we can just neglect the other terms, but we have d over r squared. So this will be equal. Okay, so we can write it as q over 4 pi epsilon naught r. And here consider that 1 minus 1. So this will be cancelled. And what we have here d over 2r cos theta. Minus time minus d over r 2r cos theta. So we can make this minus into minus plus. So this will be equal to again 2r cos theta. So just see here, both two terms are same. So that means x plus x. So we know that x plus x will be equal to 2x. Therefore, if we have the 2 times of this value, 2 and this 2 will be cancelled. So please write down in the next step what I am writing here. I can just neglect this r. So write it in the next line. We can write the pi is equal this one. Okay, so I just raised that the downside one. We already just use this idea. So I'm just deleting this. Okay. Okay, so finally, what we can have, pi is equal q over 4 pi epsilon naught r, and here we have d cos theta over, here we have 1 r, here another r. So we can have it as a r squared. Okay. And also we know that the P, the quantity of P, or we can write like this, mod of P is equal Q times D. So we can replace here the QD as P. So I'm writing here. So we can write this as P cos theta over 4 pi epsilon naught r squared. So what I'm going to do, just multiply this one, or I'm going to have the dot product of, or just unit vector r, because the modulation of the unit vector is equal 1. So if we have this one, we know that the r unit vector is equal the vector r over modulo of r. So the modulo of r we can just have as a r. So this can be write like a p dot r over 4 pi epsilon naught r squared we have. Again we have another r here. So this will be as r cube. Because we know that p dot r, the dot product p also the vector and r also is a vector. So we can have that this is equal p time unit vector r time cos theta. Okay, you can just write it somewhere here. So finally, what we can derive that the potential at a distance r from a dipole is equal to p dot r over 4 pi epsilon naught r cube. If you need some of the applications to use the charge and the displacement only, then you can just stop in this situation. Okay. For example, if the question is given for you with the information of charges and the separation, then you can just go from this one. If not, if it is provided only that dipole moment, then you need to come for this at least to this step. Okay, so now we know that what is the potential. So can you just find that electric field at the point P? So, okay, you can use that one. The electric field, we know that electric field is equal. And this, we are just considering and a dot point. So we can just use the spherical polar coordinate. If not, you can just write down here for the spherical polar coordinate. What is E? Electric field. So we know that electric field is equal to minus del pi. And in the spherical polar coordinates, you know what is the meaning of del. So can you just write down the answer, please? Please try it yourself. Okay, let's write here. The electric field E is equal minus time. Before we find the del, we need to know the meaning of the del in the spherical polar coordinate. So del is equal daba over daba r along this r direction plus 1 over r time daba over daba theta along the theta direction plus 1 over r sine theta daba over daba psi along the psi direction. So this is the meaning of del. So if we need to find that del of the pi, then I'm having this minus as it is here. So we need to have the daba pi over daba r along the r direction plus 1 over r daba over daba theta along the theta direction. So here we need to have the pi. And here, this doesn't depend on the psi. When we consider a coordinate system, the planar coordinate, then this will be equal to 0. So we can just stop with this one. So what we can have here, we know what is the potential. Potential is equal P dot R over 4 pi epsilon naught R cube. So can you tell, first find the differentiation with respect to r. Can you first find the dabba pi over dabba r? Then we can apply here, or we can substitute here. First separately find dabba pi over dabba r and also dabba pi over dabba theta. Can you do this derivation? Okay, so whoever need to go for the prayer, please you can just leave from this meeting and you can join with your prayer. Others can continue this. So here, what we can do, we can just process from this step. That will be easy because we are having in this step we are having r vector here and also r modulation here. So it will make you a bit confused. So better to go for from this one. So if we have the differentiation of this pi with respect to r, what we can have, we can first write down that common terms q d cos theta over 4 pi epsilon naught. And what is that the differentiation for the 1 over r squared? Anyone? R squared means r minus 2. Can you tell me? PS 73, PS 73. Physical science 73. Sorry? I didn't hear. Okay, some of you sent me the answer that as 2 into r to the power minus 1, but that could be possible for the integration. Okay, so differentiation, how we are doing that? If it is a power, we are having the power as it is here, time r minus 2. Again, we just redact 1 from the power. So this will be equal to minus 2 times r minus 3. R minus 3. Okay. So the answer will be equal to QD cos theta. Also, we can have this 2 here minus time 2D cos QD cos theta over, but already have 4 pi epsilon naught and R cube. R minus 3 can be written as 1 over R cube. Okay, so the dabba pi over dabba R will be equal to this one. And how about dabba pi over dabba theta? Anyone? Dear students, when you send your answer, please don't send it to direct message for me only. Okay, just share to everyone. Send your message to everyone. Okay, so some of you sent me the correct answer also for this dabba pi over dabba r. And how about this dabba pi over dabba theta? At least using this the previous idea, can you find the derivation with respect to theta? Can anyone? Can you please share your answer with me? Not only with me, just share to everyone. So when we just get the derivation with respect to theta, we can have the other terms, right? Here. So here when we know that pi is equal QD over 4 pi epsilon naught r squared. Now we are going to get the differentiation for the cos theta. So what is the differentiation for the cos theta? Anyone? Okay, that should be minus sine theta, right? So minus sine theta. So what we can have here, minus time QD sine theta over 4 pi epsilon naught r squared. Okay. So now if you know that dabba pi over dabba and dabba pi over dabba theta, now we will substitute in our E. Okay, this is E. So E can be written as minus time dabba over dabba pi is equal minus time 2 QD cos theta over 4 pi epsilon naught r cube along the r direction. And sometime most of the students miss this direction because we have the direction in that meaning of del. Definitely we need to carry this direction along with these answers. Okay, so don't forget to write these directions and this value along this r direction plus 1 over r. 1 over r. Dabba pi over dabba theta. We know that dabba pi over dabba theta here is equal to minus time this value. So if we have minus here and plus here, so I can write here minus time q d sine theta over 4 pi epsilon naught r squared along this theta direction. Okay, so if we have minus here and here also minus, this term also carry minus. So we can just cancel all these minus. So what we can have the answer here, QD. We can take all the common terms outside. So I'm going to write like QD over 4 pi epsilon naught here we have r cube and here r squared and also here r. So this also can be written as r cube. 4 pi naught r cube. Inside the bracket, if I take this term outside, what is remaining here? 2 cos theta along this r direction plus I just got the QD over 4 pi epsilon naught r cube. So the remaining one is sine theta along the theta direction. As well as if you need to write this QD is equal P, we know that this is equal P. So in terms of QD, you can write as P. In next line, please write down that this is equal to P over 4 pi epsilon naught r cube times 2 cos theta along this r direction plus sine theta along this theta direction. So this will be the electric field at a point r distance from this dipole. Okay, so now we know that how to find the potential and also how can we get the answer for the electric field. So now this is for the spherical polar coordinate. So we already know the potential here in these two systems. And now we derive the electric field for the spherical polar coordinate. So by just imaging the Cartesian coordinate, can you find that electric field? Can you please try this one for the electric field in the Cartesian system? Shall I raise them first? Have you all understood? Do you have any problem with this? Do you need any further clarifications? Anyone? PS 146. PS 146. PS 146. PS 149. PS 149.
Yes, madam.
Is it clear?
Yes, madam.
Okay, so I just raised them, okay?
Okay, madam.
Okay, thank you. Okay, so if we just got the idea for this one and try as a homework for the Cartesian coordinate system, how can we derive the electric field if we know the potential from a displacement R from the dipole? So this is now we are just talking about the dipole, and if we just have this idea for the quadrupole, and if we know the idea for the quadrupole and the dipole, we can define or derive the relationship for the multipole. So these are very deep things. So I'm not just discuss here as you are undergraduate level. So I hope this is enough for the dipole moment, but you need to know. So can you just put the title after this dipole moment? Put the title as, I'm just reading, please copy them. The torque on a dipole. So now we already know how to find the potential and the electric field. Now we are going to find the torque in the external field. Now we already know if we have the dipole and how could be the dipole moment is produced and how can we find the potential and the electric field. So now we will consider that if we have the dipole, now we are just applying the external field, external electric field. Okay. So we'll see what could happen when we have the external electric field. Okay, for example, just say that here's the plus Q charge and here's the minus Q charge. We know that it's separated by the displacement 2D, as we already defined 2D. And say this is the electric field now. Okay, so now we are having some external electric field. Okay, and say this is D by 2 from the center, and this also D by 2. That means the separations between two charges are D. So if we have the electric field in this direction, so we know that the electric field is defined by the force over charge. So what is the meaning of that? The electric field have the same direction of the force. So if we know the electric field in this direction, therefore the force also will be along this direction. For example, it will have that force on this direction, say F. So F is equal, we know that this is what we give the electric field time, the charge Q. So we from this equation, E is equal F over Q, therefore F will be equal to E time Q. So we can have this plus EQ. Likewise, in this direction, the electric field is here and we are having minus value. So for the force will be equal to minus time EQ in this direction. So how can we write this? Like in this direction, the value EQ. The minus means then that direction will be opposite, right? So just consider now here, we are having one force in this direction and other force opposite to that direction. Or at that same, by just connecting these two lines for both corners or their entered lines, but we are having the opposite forces. So if we have the opposite forces on this end of this line, what we can have, there will be a torque, right? It will be rotate like this. So what we say that as a torque. Okay, torque, this one. Okay, so after this the diagram, just write down that the torque inside the bracket, put it as a couple. The torque on the dipole is defined the notation I or the symbol I is equal, the summation of I is going Ri into Fi. So now we are considering for one dipole. If we have one dipole, we can just write down I is equal R cross F. Okay, this is cross product R cross F. Now, if we have a system more than one dipole, then we need to have the summation of all these dipoles. Okay, after this one, write down that taking moment about the center, about the center point. So center point we know here, say this is O, this is center point. Between, just continue that, between the charges. Between the charges. So if we take that moment, how can we do that? This is along this direction. The displacement is d by 2 along this direction, and we will have the same side or the same direction. See here, clockwise, right? This is clockwise, and this also going in the same clockwise. So we can have the answer as 2 times the displacement d by 2 cross the charge q time the force. We know that q into e, external field. Okay, this is external. So this can be written as the 2 and 2 will be cancelled. Therefore, we can write like a q d cross external, e electric field or external field. Okay, therefore, how can we write this? The torque, this is t, okay, t, the vector. Therefore, we are having that underline. The torque underline, because vector, we know that displacement also is vector, electric field also is vector. Okay, wherever we have these values, just write down like this one. QD, we know that QD is equal the P, also vector. So there are the cross product of the dipole moment and the external electric field, we can have the torque. Okay, please write down this. The torque will be equal to the cross product of dipole moment and also the external electric field. So under this one, write down that the magnitude of the torque, the magnitude of the torque from cross product T, the mod of T. We know that the cross product, if A cross B, then modulation of A cross B will be equal to mod of A, mod of B sine theta. And also the direction will be there, right? So likewise, the T, modulation of T will be equal to modulation of the P and modulation of the external electric field times sine theta. So the magnitude we can have using this value. And also this will be along a direction. Okay. So we know that if we have this curl and the clockwise, we can find the direction of this one. Okay. So this is the way to find the magnitude. So write down under this, there is only a couple, not traditional force, this only the couple. So that means no translational force. Okay, so this is the way to how to find the torque with the external electric field. Okay, so the time is getting for 1 hour. So I think we can stop with this one today's lecture and we can continue later. And how about for the coming week? If the strike is not, then it's not stopped, and if it is continue, and how can we arrange our lectures? Whether is it possible to give a time 2 hours, the continuous lecture for 2 hours on coming Friday? Okay. Can you hear me?
Yes, ma'am.
Okay, so just talk about with along your that mean among your friends and your colleagues who are taking physics. Okay, so just let me know that coming Thursday, most probably if it is a physical lecture, then I can take the lecture. But if it is still online, that Thursday I will not take my lecture. Okay, and Friday I can cover both of that Friday and Thursday lecture. So if we have that suitable time for 2 hours, let me know. Okay, you got my message?
Yes, ma'am.
Okay, and if it is a physical one, if that mean the strike end up and that lectures are started by physically, then coming Friday we will have our second unit exam, second continuous assessment. No any changes on that. If the lectures are physically going for coming week, Thursday I will cover the remaining lecture, and also Friday you will need to have your second continuous assessment that will be covered that Poissons and Laplace equations and their applications. Okay, you got my message? Is it clear for you?
Yes, madam.
Yes, ma'am.
Okay, thank you. So this is the thing what I want to share today. And if do you need to have any clarification? Do you need to know anything about? If not, shall we end up our lecture today? I all agree with that? Any objections?
Madam.
Yes? Okay, some of you asked which part for the exam. I already told you, like covered the Poissons and the Laplace equations and their applications. Okay. Okay, so just talk about yourself and let me know the lecture hour for coming Friday, 2 hours lecture. And thank you for your participation. Thank you.